In this video, we will be talking about acids, bases, and salts. This video was created by Tom, Zach, Morgan, Rachel, and Eden.
My topic was acids and bases. Examples of acids are grapes, lemons, and vinegar. Some bases are baking soda, Clorox, and Windex.
Properties of acids and bases. The taste of an acid is sour. The taste of a base is bitter. The touch of an acid would be like an orange. It would hurt to cut, but it tastes or feels like water. The touch of a bases is like soap. Reaction with metals. Acids react vigorously with some. Bases do not react with metals. They are both conductors of electricity and have electrolytes. And the indicator of them is if you put in like a chemical solution that an acid will turn red and a base will turn blue if you use litmus paper.
A neutralization reaction is when an acid or a base react quantitatively with each other. As you can see right here, you have the acid, which is an orange, the sodium hydroxide, which is the base, and when you add these two together, you will end up with no hydrogen hydroxide, and that is a neutralization reaction.
As defined by Arrhenius, acids release hydrogen ions when in an aqueous solution, and bases release hydroxide ions when in an aqueous solution.
My next poster is the comparison of Arrhenius and Bronsted-Lowry, and what's the differences and what's similar. So this Arrhenius has bases produce OH negative. They don't both produce acid, donate to hydrogen. The Bronsted-Lowry bases produce except H negative.
The Bronsted-Lowry definition states that in solution, acids will donate hydrogen ions, whereas a base accepts hydrogen ions. There are a few exceptions to this rule, like water. Water, according to the Bronsted-Lowry definition, is both an acid and a base.
So what are conjugate acids and bases? It's the difference of one hydrogen ion. So if you have a base and it's NH3 and you add your hydrogen atom, you're going to get your conjugate acid of NH4. And vice versa, if you have an acid of, say, hydrogen chloride and you subtract your hydrogen atom, you're going to get your base. So the acids have one more hydrogen atom and the bases have like one less than the starting point.
Strong and weak acids are sort of the same. A strong acid completely dissociates and a weak acid only partially dissociates. When an acid is strong, the weaker its conjugate base is, but when the base is weak, the stronger the conjugate acid is.
Okay, to recap, acids taste sour while bases have a bitter taste. Acids also react with most metals and turn litmus paper red, while bases have a slippery texture and turn litmus paper blue. Both are electrolytes and conduct electricity, and they both neutralize each other's properties. So, when they react with each other, they produce water and a salt. So by Arrhenius' definition, acids release hydrogen ions in water solutions and bases release hydroxide ions in water solutions. And by Bronsted-Lowry's definition, acids act as a hydrogen ion donor and bases act as a hydrogen ion acceptor. So basically, hydrogen ions are the same thing as one proton. And now to explain conjugate acids and bases, you take the acid minus the hydrogen ion to get its conjugate base, And then to get the conjugate acid, you take the base plus one hydrogen atom. Okay, so basically the stronger the acid, the weaker the base, and the stronger the base, the weaker the acid.
And that is acids, bases, and salts.